Alright, so this is an example of linear programming in Excel. This is example 3-2 in the textbook, which starts on page 52. So the first step in solving this, opening up Excel, obviously you need to have Solver installed already, and that's available in another video. The first step that I'm going to do is index these decision variables x1 and x2, and that basically just means I'm assigning cells C2 and D2 the names of x1 and x2 respectively to make it easier. So to do that, you hold down Alt, and then press I, N, and C, and you should get this little box right here. And the top row is the names, and then the bottom row is the cells, so everything's good. You hit OK. So now when you do equals and you click on this, you see it says x1 instead of C2, which is what we want. So I already have the objective functions and the constraints in for the sake of time, but we have to set up the formulas. So the formula for the objective function is 3x1 plus 9x2, as you can see over here. So we're going to set that up equals 3 times x1 plus 9 times x2, and then as you can see, the value is 0 for now because we don't have values in here, but if you added values, you can see it'll change. Then we'll set up the first constraint, which is you need a weekly requirement of 100 tons. So we'll set that up equals 40 times x1 plus 15 times 2. And with the values that we have currently, that's 55, and you can see that that constraint has to be greater than 100. We'll do the same, and in order to cut down on the time, I'll just fill this down. So basically what I did there is since we had these in rows, you can just hold Control and hit D, and then it copies the same formula down to these cells, which is what we wanted. And now we have to set up the solver. Since all our equations are set up, we have to set up solver. So we'll go over to data and hit solver. And our objective, that's going to be E5, and we want to minimize that because that's the total cost, as you can see in this fourth row here. Our variable cells are going to be these two right here, and then we're going to add the 4 constraints. So we need this cell to be greater than or equal to this constraint. So there's our first constraint. We want this to be greater than or equal to that. Reference is less than or equal to that. And our last constraint, that. Now we have our 4 constraints set up, so we're going to go ahead and hit solve. Hit OK, and as you can see, the solution is we need 5 for x1 and 2 for x2, and we get a minimum z value of 33. And as you can see, the limiting constraints are these bottom 3 right here, 2, 3, and 4. So that's how you solve example 3-2.